how they plugged the Colorado to raise Hoover Dam in a black canyon. Let me set the scene. It's early 1931, and 6 construction companies just did something most people in the industry thought was insane. They formed a joint venture called 6 Companies, Incorporated, and they won the bid to build the tallest dam in human history. Not the tallest in America, the tallest anywhere, and that came with a catch that would test every engineer involved. The Colorado River was still running wild through Black Canyon, right where they needed to build, and the river wasn't in a cooperative mood. Here's the problem in its simplest form. A dam needs dry ground to stand on. It needs a solid foundation, bedrock, something that can hold the weight of millions of tons of concrete and billions of gallons of water. But the only ground available is at the bottom of a river. A very large, very angry river. You can't just ask the water to wait while you pour the foundation. Rivers don't take requests. So the engineers were staring at an impossible assignment. Build a dam in a place where a dam cannot physically exist yet because there's a river occupying the space. The canyon walls are nearly vertical, rising hundreds of feet straight up. There's no floodplain to spill into, no wide valley to work with, just a narrow slit in the earth with a brown monster running through the bottom of it. And here's the number that kept everyone awake at night. The Colorado River, at peak flow, can carry enough water to flood an entire city in a matter of hours. We're talking about a river that drains snowmelt from the Rocky Mountains, across the Colorado Plateau, through the Grand Canyon, and down into this narrow Black Canyon. When that snowmelt hits in late spring, the river swells. It becomes a churning, brown, silt-laden force that can rise and fall by 40 feet in a single season. Floods came without warning in those days. There were no upstream dams to regulate the flow, no reservoirs to absorb the surge. The river was wild, in the truest sense of the word. So the question becomes, how do you build a dam in the middle of a river that won't stop flowing? The answer, the one that nobody believed at first, was that they didn't just divert the river. They plugged it completely, and then they built the dam on top of the plug. Let me explain what that actually means, because the scale of this thing is hard to wrap your head around. Before Hoover Dam, if you wanted to build a dam on a river, you used a cofferdam. That's a temporary wall, usually made of earth or rock, that you build around the construction site to hold back the water. Then you pump the water out of the enclosed area, and you've got a dry space to work in. It works fine on small rivers. You build a little wall, you pump out the water, you pour your concrete, and you're done. The Colorado was not a small river. A cofferdam on the Colorado would have been washed away in the first spring flood. The river was too big, too violent, too unpredictable for that approach. The engineers at Black Canyon had to think bigger, much bigger. Their solution was to bypass the river entirely. They would carve 2 enormous tunnels through the canyon walls, redirect the entire river through those tunnels, and leave the original riverbed completely dry. That dry riverbed would become the dam's foundation. The tunnels had to be built first, while the river was still flowing, because you can't just shut off the Colorado while you do your excavation. The river doesn't care about your construction schedule. So they had to drill, blast, and dig their way through solid volcanic rock, working from both ends of each tunnel. The river kept flowing right past them, completely indifferent to the fact that humans were trying to tame it. Now let's talk about what these tunnels actually were, because calling them tunnels doesn't do them justice. These were underground highways. Each one was 56 feet in diameter. Let me put that in perspective for you. 56 feet is roughly the height of a 5-story building. You could drive a semi-truck through these tunnels with room to spare on every side. Combined, the 2 tunnels stretched about 2.5 miles. The total excavation was over 700,000 cubic yards of rock. To give you a sense of that volume, imagine a football field. Now stack rock on it to a depth of more than 400 feet. That's how much material they had to remove, by hand, with pneumatic drills, dynamite, and shovels, in temperatures that regularly exceeded 110 degrees Fahrenheit inside the tunnels. The drilling crews would bore hundreds of holes into the canyon walls, pack them with dynamite, and blast the rock loose. Then they'd shovel the debris into trucks and haul it away. The work happened in shifts around the clock, 7 days a week. The dust inside those tunnels was so thick that many workers developed silicosis, a lung disease that killed some of them years after the dam was finished. They didn't have proper respiratory protection back then. They had bandanas if they were lucky. And here's the precision problem that makes this whole thing even more remarkable. The tunnels had to meet in the middle. 2 crews working from opposite ends of the canyon had to align their excavations perfectly. A few feet of error would have meant redoing months of work. The engineers used survey stakes, plumb lines, and theodolites to keep the tunnels on course. When the crews finally broke through, the alignment error was less than a few inches. In a tunnel 56 feet in diameter, carved through solid rock by men with dynamite and hand drills, that's almost unbelievable. Once the rock was excavated, the tunnels were lined with concrete 4 feet thick in places. That lining wasn't just for structural strength. It also reduced friction, which allowed the water to flow faster and reduced the risk of erosion. The tunnels were built to handle the full force of the river at its most violent, when snowmelt and spring rains combined to send a wall of water down the canyon. The tunnels took about a year to complete, and they consumed a huge portion of the project's budget and labor force. But once they were done, the stage was set for the most dangerous part of the entire operation, stopping the river. Let me walk you through what that involved, because this was the moment of truth. The engineers had to close the river's path and force it into the tunnels. This was not a gradual process. It had to happen fast, and it had to happen perfectly. Any failure would mean the river would overtop the temporary barriers and destroy everything. The plan was to build 2 temporary cofferdams, one upstream of the dam site, one downstream. These were walls built from rock, gravel, and clay designed to hold back the river while the permanent dam was under construction. The upstream cofferdam was the critical one. It had to withstand the full pressure of the river, which could rise dozens of feet behind it. But here's the tricky part. You can't just build the upstream cofferdam in the middle of the river. The water's too deep, too fast. So the engineers had to work from the banks, dumping material into the river from both sides, gradually narrowing the channel. As the gap narrowed, the water velocity increased. The river became a torrent, a churning, frothing monster that was moving faster and faster with every load of rock that went in. The workers had to operate from platforms suspended above the gap, dumping material into the churning water below. One mistake, one slip, one miscalculation, and the river would have swept them away. The final closure took about 30 hours of continuous work. 30 hours of non-stop dumping, with the river fighting back the entire time. The engineers had calculated the flow rate, the velocity, and the volume of the river with precision, but the river didn't always cooperate. A sudden flood, a change in the weather, a surge of snowmelt from upstream, any of those could have overwhelmed the operation. The workers were racing against the river, and they knew it. And then, finally, it happened. The last load of material went in. The gap closed. The river, for the first time in millions of years, was forced to follow a path chosen by humans. It surged into the diversion tunnels, roaring through the darkness of the canyon walls, and the original riverbed went dry. I want you to think about what that moment meant. For millions of years, the Colorado River had carved its way through Black Canyon, cutting deeper and deeper into the rock. It was one of the most powerful forces of nature on the continent. And on that day in November 1932, a group of workers in hard hats and work boots stood on the banks and watched that river give up its channel. The riverbed below them, where water had flowed since before humans existed, was now dry ground. Muddy, yes. Soggy, sure. But dry enough to walk on. That dry riverbed became the foundation for the dam. The workers cleared away the mud and silt down to solid bedrock. They drilled and grouted the rock to create a watertight seal. And then they started pouring concrete. Now, the concrete pour itself is a story worth telling. The dam was built in blocks, each one about 50 feet square. The blocks were poured in layers, and the gaps between them were filled with grout to create a monolithic structure. The entire dam contains about 3.25 million cubic yards of concrete. Let me put that number in perspective. That's enough concrete to pave a 2-lane highway from San Francisco to New York. Cross country. With concrete left over. But here's the engineering challenge that most people don't know about. Concrete generates heat as it cures. If you pour too much concrete at once, the heat builds up and the concrete cracks. A cracked dam is a failed dam. So the engineers had to think creatively. They embedded cooling pipes in the concrete, circulating cold water through them to draw the heat out. It took years for the concrete to fully cure, but the cooling system prevented the massive cracks that would have destroyed the structure. The diversion tunnels were still carrying the river during most of this construction. But once the dam was tall enough, the engineers had to seal those tunnels and force the river to flow over the dam's spillways. That meant plugging the tunnels with concrete, a process that was almost as dramatic as the initial diversion. The tunnels were closed with massive concrete plugs, some of them more than 100 feet long. The concrete was poured in stages, using the same cooling pipe technology to manage the heat. If the concrete had cured too fast, it would have cracked and leaked. The engineers had to control the temperature with precision, and they did. Once the plugs were in place, the river had nowhere to go but over the dam. Lake Mead began to fill behind the wall, slowly rising, covering the old riverbed, the cofferdams, and the temporary structures. The river that had once carved through that canyon was now a reservoir, a man-made lake stretching for miles. Here's what I find most fascinating about this whole story. The techniques developed at Hoover Dam changed the way engineers approach rivers everywhere. The idea of diverting a river through temporary tunnels, building a dam in the dry riverbed, and then sealing the tunnels became the standard for large dam construction around the world. Glen Canyon Dam, built upstream on the Colorado, used the same diversion tunnel approach. So did the Aswan High Dam in Egypt. So did the Three Gorges Dam in China. Every major dam built in the decades after Hoover followed the blueprint that 6 companies developed in that Black Canyon. The plumbing of rivers became a discipline of its own, and Hoover Dam was the proof that it could be done. But I also want to be honest about the cost. More than 100 workers died during the construction of Hoover Dam. Many of them died in accidents, falls, equipment failures, explosions. But others died from heat stroke, carbon monoxide poisoning, and silicosis from the dust in those tunnels. The plaque at the dam lists 96 names, but the actual number is believed to be higher. Some workers died off-site in hospitals weeks after their accidents. Some died years later from lung disease. Their names aren't on the plaque. The project was a triumph of engineering, but it was also a human tragedy. And I think it's important to hold both of those truths at the same time. The dam is a marvel. The men who built it paid a price. There are also environmental consequences that the engineers of the 1930s didn't fully anticipate. The dam created Lake Mead, which supplies water to millions of people across the Southwest, but it also disrupted the river's natural flow. The sediment that used to travel downstream, enriching the floodplains and building the delta, now settles at the bottom of the reservoir. The ecosystems downstream changed. The river that once flowed to the Gulf of California now often runs dry before it reaches the sea. I'm not telling you this to diminish what was accomplished. I'm telling you because the full story is more interesting than the simple version. The plug that stopped the Colorado was a turning point in human history. It marked the moment when humans demonstrated that they could control a major river completely and permanently. That power came with consequences, both good and bad. Let me close with this image. Stand at the base of Hoover Dam and look up. The concrete wall towers more than 700 feet above you. Behind it, Lake Mead stretches for miles, a blue expanse of water in the middle of the desert. The Colorado River, once a wild and uncontrollable force, now flows through turbines, generating electricity for millions of people. The plug that stopped the river was not a single act. It was a sequence of decisions, each one building on the last. The tunnels, the cofferdams, the closure, the sealing. All of it was part of a single plan, executed over years by thousands of workers. Many of them never lived to see the finished dam. They died in the tunnels, on the cliffs, in the heat. They died so that a river could be moved aside, so that a dam could rise, so that cities could grow in the desert. The river didn't disappear. It's still there, waiting behind the dam, doing what it's told. But the engineers who plugged it knew something that we often forget. Rivers are not enemies to be conquered. They are forces to be understood. The plug didn't destroy the Colorado. It changed the river's job. And that change, for better or worse, shaped the American West. So next time you turn on a light, think about the river that powers it. Somewhere upstream, there's a plug, a tunnel, a dam, a system that someone built to make your life possible. And if you ever get the chance to visit Hoover Dam, stand at the base, look up, and ask yourself, how did they do it? The answer is in the rock, the concrete, and the river itself.